Hey everyone, welcome back. So previous episode we talked about how to build a full stack application using Anthropic Claude Code. So in this episode, I want to show you guys a full migration from the Gradio front end and now to React front end. So with that being said, let me share my screen. And once again, as a reminder, we're going to do this completely live just to give people a holistic view and experience of using Anthropic Claude Code. So this is the interface that I'm on right now that I have been developing. It's the same API call behind the scene. It's the same infrastructure, and the only thing different is the front end, right? Right now, the front end is React. And with all that being said, let me show you the Claude code just a little bit. And let me see if I can find the architectural diagram. Um, so that we can kind of like walk through the ideas a little bit here, what's going on. So this page called Deep Search, that is 123, the third page in the middle. And it's actually a multi-agent framework. So how it works is this. I have a prompt, right? And the prompt could be maybe non-trivial. In this case, I say, hey, I live in White Plains. I'm going to move to Seattle completely. I have three family members, four cats, whatever, right? What do I do? Um, so when humans uh, interact with this prompt, immediately how human brains work is to first of all gather the intel, right? And here the prompt is actually very vague. There's no date, there's no preferred travel approaches. The only thing is basically the location, destination, the family members, things like that, and that's really it, right? So we're not talking about a whole lot of constraints here. I am pretty much, even if it's a human handling this, you can just, run wild, right? Like, how about flying? How about taking a car? Like, what are you gonna do with the cats, right? Like all that stuff. So that's kind of the problem statement that we're trying to solve, right? When the prompt looks like this, that perhaps require multiple steps of interactions and thinking. How do we put together a system to tackle this kind of a problem, right? So that's the problem statement. That's what we're doing here. And hopefully in this video, I can show you guys a little bit of a system diagram to help you understand what are some of the basic building block required to put together a system like this. But before we jump into the technicalities, let's take a look at the execution log. Let me zoom in. The execution log says something like this, right? Okay, initializing planning agent. That's the query we're trying to analyze. The plan created is user wants to relocate their family member of whatever from A to B, right? And we need more guidance. Great. Does it require specialists? Answer is true. It requires specialists. So now we're talking about this agentic framework, right? The planner knows the planner cannot solve the problem himself. The planner requires help of other people. That's what the specialists come in. Great. So the planner, I've identified five tasks, right? So let's see what they are. Task one, it's a web search. Search for comprehensive moving checklist and timeline for cross-country relocation from New York to Seattle, right? Great. That's first search. Second search, task two, it's also a web search. Search for pet-friendly moving companies that handle cross-country moves from New York to Seattle and their requirements for transporting four cats. Okay, something to do with pets. That's what I want to know. And that will be an independent search. Makes sense. Task three, search for Seattle neighborhood information, cost of living, comparison with White Plains, so on and so forth. Wait, I actually did not say anything about whether I have a house or not, right? That remains to be a question. So I'm actually fascinated that LLM actually has housing as one of the to-do items. Great, that's one of the tasks. Next task, search for Washington State requirements for new residents, including driver's license, vehicle registration, pet licensing requirements, things like that. Okay, that's another search, something to do with the destination, right? Something to do with the new residents, driver's license, things like that. Task 5, create a simple HTML page with all the checklist timeline, all the information gathered together in different categories, so on and so forth, right? That's the plan. Okay, so 5 steps. First 4 steps are just internet searches of particular query. The last step is you write a thing together, right? So in some sense, this last step, task 5, is kind of like uh, a documentation agent, right? The agent's goal is to take all the intel and document it. So one interesting thing about the design here is the user experience. The user need to be prompted that that's the plan. The user also now need to wait for the plan, right? And if you think about this task a little bit, the task 1, 2, 3, 4 actually can be parallel, right? I don't need to wait for the first guy to finish searching for comprehensive moving checklist in order for me to conduct another internet search for pet-friendly moving companies, which is task 2, right? You get the idea. These two tasks are not dependent of each other. So what that means is task 1 and 2 can be parallelized. Great. And that's exactly what's happening here. We're going to parallelize task 1, 2. And if you can understand that, you get the idea of 3 and 4, and so on and so forth, based on the number of tasks that the planner agent come up with. So that's the idea here. And then obviously the task 5, which is the last specialist that's putting together this documentation using a HTML page. He will, of course, have to wait for everybody else, right? So, unfortunately, this last person cannot be paralyzed. He has to wait for other people to finish their job. But overall, together, the first 4 can be paralyzed. So that's the idea, right? So immediately based on task 1, 2, 3, 4, that's coming up, that's in this plan that the planner agent cooked up, you immediately get the idea what need to happen, right, on a hierarchical level. Um, so the rest of the step is just executing the plan, and that's exactly what's happening here. The orchestrator agent now comes in and say, okay, I'm gonna dispatch the job of task 1, 2, 3, 4 to all these guys, and you guys just go do your job, right? So that's orchestrator agent function, and that's what the executing plan means here. So when users using this experience, this will be prompted as it goes, right? And this is connected up and live with a server-side endpoint. So great. Now user wants to do this, organize into 2 execution wave for parallel processing, wave 1 and wave 2, right? Wave 1 is executing 4 tasks, 1, 2, 3, 4, and you wait a little bit, right? Each task maybe take a little bit of time, right? Not the exact same time, task 1 in progress, 1, 2, 3, 4 in progress, 1, 2, 3, 4 in progress, 1, 2, 3, 4 in progress. You get the idea, and then somewhere down here, one of the tasks finished. And here, interestingly enough, the task 4 actually completed first, right? And then task 2 completed, and then so on and so forth, 1 and 3, right? You get the idea. Each take a different number of seconds. Okay, so that's the first wave of execution. Now comes the second wave of execution, right? The second wave of execution is just one task, right? It's that guy in the end that basically put together all the documentation. And in this case, the documentation is, you can think about it as some sort of a HTML page, right? Just for simplicity. So user can read about it, they can display it, they can, put it on the marketplace, so on and so forth, right? Great. So now that we're on the same page, the task 5, which is a web builder, that's the specialist name, that's going to put together a website, right? And maybe it take him, I don't know, 49 seconds. Once it finishes job, then the deep search process has completed. Once it's completed, you can then go to the right-hand side and check out the result. Preview. This is the cross-country move. Um, that's the title, moving timeline, research planning, maybe 8 weeks, book the services, maybe 6 weeks. The 4 weeks is notification, final preparation, 2 weeks. Final week is the last week is just moving, pack the essentials, things like that. So this will be the moving timeline from the longest of weeks all the way to like 1 week ahead of the move, right? And then the recommendation here is 8 weeks. Um, I'm personally doing this. I don't think 8 weeks is enough. Um, but realistically speaking, for a move like this, also you have day job, you have other things going on in your life. I think 8 weeks, we're talking about 2 months, right? So 2 months ahead of a actual move, is when you really need to get your shit together and then really need to start doing things. So I would say this is just, realistically speaking, pretty consistent with what I'm personally experienced. So I would say that makes sense. Checklist, great. Before move, XYZ, right? Do your thing. You can check this if you want to. It's a web page there, right? Once it's saved on your computer, you can come back and revisit it, right? After move, you need to do blah blah blah, check this. If you've done something, check this, right? Insurance policy, things like that. Um, I actually, uh, you know, the first time for me to move a car from one state to the other, especially across the country, so all this stuff is new for me. So obviously, this is going to be a learning progress. So I'm actually glad to see that this is a good confirmation for me that's showing up here on this documentation. Pet friendly, right? Different airline, van line, right? I think here focus on van line. Somehow it's not talking about airlines. So that's interesting. That means I need to come back up to update the prompt a little bit. Maybe it will have a better documentation there. But in regards to the cost, it's pretty much consistent with what I already know. So great. Seattle neighborhood, right? Capitol Hill, Fremont, Ballard or Ballard. Great. Moving costs. Okay, so this is the estimated cost. A moving company, I would say this is pretty consistent with what we've seen. Pet transportation, I think it'd be really difficult to get away with a few $100s. I think based on all of the investigation we've personally done, um, we're talking about thousands dollars. You want to probably go with $1,000, $2,000, considering we have 4 cats, right? And then the travel expenses, I'll probably say, um, for 2 people, that's probably on par. But if you're gonna go for 3 people, 4 people, like especially when you're moving your cats on a plane, then it's per person per cat. Then obviously that number is not gonna work, right? We're talking about a much bigger number. Um, we're not doing storage. It's a full move. So there's no storage talking about. So that's kind of like optional, makes sense, right? If needed. I would say total estimate is around the ballpark, equivalent to what I'm personally spending. If not, like this is probably a little bit more conservative. What I'm personally spending probably is going to be more than that. And but it's interesting to see the major items is pretty much consistent, right? Um, Washington state requirements, license, vehicle registration, pets, right? Things like that. And good luck with cross-country move. Great. So that's why we're here. That's the end game. Now let me show you the system architect. So in terms of system architect, I just have Anthropic Claude to write it out based on the code that's being written, right? That's like the clearest way. So architecture, planning agent. Planning agent is a function, right? It's a function. It's a function that comes up with the plan. And what the plan is essentially a JSON file that has empty spots in the middle, right? And then when you create the JSON file, make sure you have a correct schema. And the schema need to be clear enough so that the orchestrator knows what to do, right? Like for example, here, of course, you need to say whether you even need a specialist, right? Obviously, that's one variable or one key that you need to build in a schema. What kind of tasks are we talking about, right? If you do require specialist, what is a specialist, right? Here, one of the specialists called web search. Great, that's a function call. Then that's going to be what's needed downstream in the workflow. Description, so on and so forth, depends on whatever, right? If it depends on something, that means we need to have a different wave of execution, right? If it doesn't depend on anything, then it can be paralyzed, right? So this depends on key is going to be extremely important for when you come up with a plan of all these different tasks. The orchestrator will then know which can be paralyzed, which cannot. Okay, so that's the depends on. And once you understood this, it pretty much is a very good schema, at least at a basic level, to come up with that plan. Great. So now you have a plan. Now you need to go get it done, right? Okay. So that's when the next agent comes in, the orchestrator agent. So orchestrator agent, that's what's happening here. His job or her job is to dispatch the specialist and make sure they do their job, right? And in this case, as we discussed before, we have task 1, 2, 3, 4, 5. 1, 2, 3, 4 is independent web search, so they can be parallelized. Task 5, depending on everybody before, so task 5 need to wait a little bit, right? Um, so when each specialist returns with a bunch of things, then it's gonna be its sub JSON structure, right? And then the sub JSON structure can be attached to the main JSON structure, and then altogether you have a holistic plan, right? Um, so that's what the orchestrator agent is doing. And then once the specialists return all these sub JSON file, the orchestrator agent will then put it back, right? And then the way to do that is called synthesis. So synthesis means you combine the results of all of the specialists that you've been using into that final answer so that you can then, I don't know, put together documentation, write it up in terms of some sort of a notebook, or in this case, because I'm talking about web app, right? So I'll just build a web app for you so user know what's going on, right? So there you go. If you can understand, these three boxes, I will say you understood pretty much, over 90% of what's happening on this page, right? And then to make things a little bit more stickier for the community, I also have a little bit of a save button down here because I don't want user to lose this, right? Because this is like things that, me personally, I will probably want to come back for, right? So I have a login here designated to each particular user, I have a session ID, so on and so forth. Maybe the project here is um, move across country, something like that. I say save current, it'll be saved locally, and then the move across country is here. I can always load it back, and I can go to my drive, and let me refresh, and then hopefully there is uh, file that I just created, which now I can't find. That's alarming. Let's refresh again. Um, Let me see this one. That's Hello World. This one is a Tesla analysis. This one's Hello World again. Hello World Coffee. Oh, maybe that function is not implemented correctly. But I'll have to implement that function. But then after that, it will show up in the marketplace place, just like this, right? And then user can then comment on it, so on and so forth. And then you can even trade ideas, right? So a lot more things are upcoming. There's small bug here and there I have to fix, but that's essentially the idea. Thank you for watching. Hopefully you like the video and hopefully this video sheds some light of what it takes to put together a multi-agent system with planner, with orchestrator, with different specialists, right? And then, yeah, thank you for watching, and I'll see you in the next video.